Should we start? Is there anyone against the fact that we start now? Right? I know it's 5 p.m., almost beer time. On peut faire avec ça.
But nice, there is many people attending to the last session, so it's cool. Ça marche plus?
Ah si, c'est bon. Okay. Thank you for attending this session. It's the last one for this day, for today. It's great to see you, that you're still interested in what we are going to talk. Who framed RabbitMQ? Yeah, let's discover that. So first, my name is Arnaud. I work for OVHcloud.
And my name is Julien, and I'm working for OVHcloud since 12 years now.
Yeah, so what we do at OVHcloud is we work on OpenStack, of course. We deploy OpenStack, we manage the public cloud product, infrastructure. We have like too many servers, too many computes, too many regions, too many RabbitMQ to manage, too many control plane to manage, too much OpenStack regions, too much OpenStack versions. Old OpenStack version as well. I won't say the name of the old OpenStack version. But we are also running OpenStack Caracal, which is pretty new. It's okay. And it works. And we upgraded a lot of stuff on this. So, what are we going to talk about today? We will start by trying to figure out who framed RabbitMQ first. Then we will try to troubleshoot what's wrong with the RabbitMQ server cluster. Then Julien will explain a little bit what is under the hood, what is behind Oslo messaging. Then we'll try to understand how we can fix what we did, what we will do to make the cluster up and running and fine. And then we will conclude by trying to learn something from this journey. Okay? First, who framed RabbitMQ?
So to get a bit of context, so when we are talking about issue with RabbitMQ, we are talking issue mostly of in our biggest region. So like Arnaud said, we operate many OpenStack region in production. And most of them have more than 1K compute node, and even some of them goes up to 2,000 compute nodes. So first, what we can see when we have some issue on our region, we see a lot of also messaging RPC timeout. So in all OpenStack component log, we can see those error message. So it means that the component didn't get any RPC reply. So it can be a broker issue. It can also be a component, OpenStack component issue. But mostly when we experience a RabbitMQ issue, it's full of these logs. We get also a lot of missed heartbeat error. So what is a heartbeat in RabbitMQ? It's a mechanism both sides of the connection in RabbitMQ send periodically heartbeat. And when one side didn't get this heartbeat in the expected time, the connection, the TCP connection is closed now. And then the component have to reopen it back. So we had a lot of these error message in logs. So it seems to be, we contacted, we sent a message on community. It seems to be a non-issue. since long time, and we try to figure out what's the root cause. We also get sometimes network partition. So when there is networking issue, Rabbit cluster get to partition node. So depending on the partition handling mechanism, so we are using pose minority on all of our infrastructure. So the minority, the quorum will stop, and then all connection issue to the stop node will have to fall back on other nodes in the cluster. So it generates a lot of pressure, a lot of new TCP connection, a queue declaration on the rest of the cluster. And we also get sometimes unresponsive cluster, mostly due to this network partition issue. So yeah, there is sometimes where RabbitMQ, CTL, API, nothing answer anymore. And so a lot of error, no Prometheus exporter metrics anymore. So unfortunately, our solution to fix that is just resetting the RabbitMQ cluster to restart from scratch. So that's bad because we can lose some event, some message which are transiting in the cluster during this time frame. And for sure, we have after that some inconsistencies in OpenStack, some in OpenStack objects. And also the loss of one node. If there is a lot of non-HAQ, like transient queue, there is a lot of reply queue or fan-out queue, etc. So those are transient queue, and if we lose one node, all of those queues are lost and need to be recreated. So yeah, it's not always easy at large scale, but we will need to figure out how to do better.
Yes. So now we identified, we have some issues. Let's try to troubleshoot and identify where those issues are coming from. So first, what we did, we improved our observability. That sounds obvious, right? We deployed some Prometheus exporters. We installed some Grafana graphs in order to take a look at what's going on the cluster. We also used a project from OpenStack named Oslo Metrics, which is very nice because it can help you monitor what are the RPC calls done by which component inside OpenStack. This is very, very nice. And we did some smoke ping between cluster nodes in order to monitor the networking partition or the issues between the nodes in the cluster. We also take a look at logs, and we also improved the logs statement inside our agents. So this is an example of logs from like I don't know if it's Nova or Neutron, but we can see here that we are calling a RPC method named report state. So this is Neutron. So this is something which is called by an agent. So Neutron agent will do this call. If you don't have this kind of information in logs, you don't even know. You are blind on what is currently happening on the OpenStack cluster. So we did that. We also added some in logs message unique IDs. Sometimes when an agent is sending a message, it expects a reply, and if you don't have the name, the ID, the specific unique ID of this message, you can't even track the fact that the reply is lost somewhere. By printing IDs, we can track them. So it's pretty useful. What we also did is we talked with the upstream community. Actually, we talked with two upstream communities. OpenStack community first, and RabbitMQ community as well. That sounds also obvious, but this is one of the key points of what we did in order to make our cluster to troubleshoot what's going wrong on our cluster. We also improved our tooling. We improved based on what we were currently doing. When we try to debug a cluster, we built some Bash script or Python tool to communicate with the RabbitMQ API or even collect data on some of the agent or stuff like this. So we did a lot of tooling around the debugging session in order to monitor it in a better way. And then what do we learn on this? We learned that Neutron is the bad guy. Sorry. Yeah. This is what we learned. So we learned that from Oslo metrics first, that most of the messages that Neutron is sending are sent on fanouts. So fanouts are queues where you send a message, one message, and it's spread over all the OpenStack agents. So if you have more than 2K agents, only one message will be spread on 2K agents. This is fanout. So we were flooded by messages like this. We learned that. And we have a lot of agents on our side because we deploy two agents, WAL and free agent, metadata agent, DHCP agent. So you can imagine each of them is doing a lot of TCP connection to the cluster. Each of them is starting creating a lot of queues. So we have a lot of queues on the Rabbit cluster with a lot of message going through it. It's very it's huge. So we learned that at least. What we also learned is that Nova is not as bad as Neutron. Why? Mostly because the architecture design is different. We have only one agent, and I think it's the same on your side. You have Nova Compute, usually, which is one agent, talking to Nova Conductor, and that's it. So it will create less queues, less TCP connection, but what we learned is it's sending much more messages. That's weird. Neutron is having much more agent, much more queues, but sending 5 times less messages than Nova. We also tried another tool, which is RabbitMQ perf test. So this is based on a discussion with the community on the RabbitMQ side. They said, hey, maybe you can try to reproduce your load, but not on a production server, not a production cluster, but in a predictable environment. So we deployed RabbitMQ perf test. It's basically a Docker container that you can use to simulate consumers, queues, clients, and a lot of parameters to build something which looks like an OpenStack deployment at large scale. And what we learned from this is that RabbitMQ is a message broker, not a queue connection broker. And this is very important because OpenStack is relying on creating a lot of queues on RabbitMQ, but for very few amount of messages. But when we talk about this with the RabbitMQ community, they said, you're using RabbitMQ the wrong way. The good way is to have few queues, but a lot of messages. So what's under the hood? Who is in charge of creating all of these queues?
So Oslo Messaging. Oslo Messaging is a library used by all OpenStack components to do RPC. So with RabbitMQ as there is some other backend maybe. I know that for some events you can use Kafka, for example, but not everything is implemented as a backend. So the most common used is RabbitMQ. So Oslo Messaging is mostly the RPC library used to talk to RabbitMQ. So how is it working? It exposes some API to create a RPC server. So when you declare a RPC server, you will create a RPC server with a topic name. And this RPC server will create 3 queues, one dedicated for a different type of communication with the client. And it will also create a dedicated TCP connection. So here there is an example how RPC server is created. So we pass some endpoint RPC methods. It's basically a Python class with a different method, which will be called by clients. So on client side, so clients will use will need to call RPC server, so they will call RPC method, like report state, like many others actually. And so to call RPC method, the client will have to declare on which topic he wants to talk. And after that, Oslo messaging is implementing different methods. So there is basically call and cast. Call method is the client will publish a message and expect a reply. So it will expect a reply in a reply queue. So there is a lot of queue created on the broker. Each client will create its own queue, reply underscore, and there is some random ID behind them. So each time the client expects a reply, it will send a message to a topic, so in a queue, and listen to this reply queue to get the answer back from the server. And there is also cast method, so it's basically the fan out false. It's basically the same, but it doesn't attend any reply at all. So it's mostly to notify server for doing some action without expecting a reply. And there is this cast with fan out to true. And this one will contact, will send a message to all, to basically to everyone binded to those queues. So it's like it's a broadcast. So here is an example of how look an Oslo message transiting in RabbitMQ. So there is a method, the payload, and there is in some metadata. So there is the message ID, and also here we see that there is a reply queue in the payload. So it means that it's a method call, and the server will have to reply the answer in this queue.
Non,
c'est l'autre.
Thank you. Now that we know how it works under the hood, now that we know what's wrong on our cluster, let's try to follow the right way to manage or to use RabbitMQ in OpenStack. Let's try to take a look at what we did first to improve our stability. So first, what we did is we upgraded RabbitMQ. Yeah, that sounds obvious as well, but if you manage a production cluster on your side, you know that upgrading RabbitMQ is not that easy, right? If you manage 40 production regions, it starts becoming very challenging, right? So we did 2 upgrades, actually. One upgrade, no, we did a lot of upgrades, but in this history, we started from 3.8 up to 3.12. On 3.12, we did a lot of other stuff that we are going to talk about later. And recently, we upgraded to 4.1. 4.1 is, each time you upgrade, each time you get stability. So if you have a problem with RabbitMQ, first, upgrade, right? It's good, it was better, but it's not enough. What we also did is we tried to avoid missing some heartbeats. because it's accepted by the community. It seems it's not affecting the service, but let's try to fix it anyway because it's polluting logs, and maybe it will improve the stability anyway. So what we figured out is that we were using the wrong NPM backend on Apache. We were using the worker NPM backend, which is wrong. And we switched to event, and then part of the missed bits were gone. That was better. So if you don't know which backend you're using on Apache, if you're using Apache for WSGI application on OpenStack, switch to event. It will be better for you. Second thing, we took a look at the Oslo messaging code and especially the event-led green thread and all of this very weird way of managing threads on OpenStack. And we figured out that a lot of fixes were done by Red Hat guys, thanks to them, but some of them were not yet finished. So we finished the work, and we were able to move the heartbeats from a green thread to a Python thread, a native thread, and that improved a lot the heartbeat mechanism as well. And finally, we discovered a race condition in PyIMQP library, which is under Oslo messaging, that prevented the heartbeats to be sent at a correct period. And a race condition was also a problem on our side. We fixed that. Was good, but not enough. What we did after is we introduced Quorum queues on our system. What are Quorum queues? It's a new way to do HA queues on RabbitMQ. RabbitMQ is moving away from classic HA. So if you don't know if you are using that, then you are using that. And we are, you must move to Quorum queues in a very short amount of time because RabbitMQ 4 is anyway dropping classic HA. So you have to move to Quorum queues. So we decided to move to Quorum queues before moving to Rabbit 4, and that solved a lot of issues. But Oslo messaging was only partially using Quorum queues. For transient queues like reply and fanouts, it was not yet implemented. So we introduced this new Rabbit transient Quorum queue parameter inside Oslo messaging, which is now available since Caracal, if I'm correct. And you must turn that to true as well to switch completely to Quorum queues. That was amazing. We support now a node loss because all our queues are HA, even the reply queues. That's good, but not enough. It's bad because it consumes a lot of CPU. So if you switch to Quorum, you will see an increase on CPU side, RAM size, network size. It's amazing. And also we discovered that the queue churn is killing our server. Our cluster was completely dying because of the deletion and creation of queues. And deletion of creation of queues is very expensive on RabbitMQ side. And that's where we introduce the queue manager mechanism. So this is a patch we did in Oslo messaging as well, which is false by default, but you can switch it to true since Caracal. And it will allow you to have some, instead of having random name in queues, you will have predictable names. So you will switch from a queue named like this to something like this, which is definitely better because it's predictable first, but also you know that it's a queue for a neutron BZP agent on this host. So when you list your queues, you see which queue is broken for which compute and which agent. And it prevents queue churn because as soon as you restart neutron agent, now it will reuse the same queue instead of deleting and create a new one. That was good, but not enough.
And we just figured out that we were still having too many queues on our cluster. So we dig a little bit on RabbitMQ documentation, contacted community, and string queue is a new type of queue that has been introduced in RabbitMQ since Rabbit 3. It's pretty recent. I don't remember which version it was introduced, but according to RabbitMQ documentation, stream queues are just for the large fan-out purpose. So it's a really good concurrent to replace our Quorum queue fan-out. So let's take a look at how stream queues are working. So a classic queue in Rabbit is dedicated to one consumer. So one consumer declares its queue and consume message from it. With stream queue, there is one queue shared between n consumer. So it's a HAQ, and it's a log append only data structure. So it means that a publisher will append some message. It will be stored on disk. And to consume some message, consumer will have to connect to this queue and consume from an index, so called the offset. So if needed, a consumer can reconnect to a dedicated offset and start consuming from this one. So from NQ, because each agent declaring its own dedicated fan-out, we now have just one queue per topic shared between all consumers. So you can just enable that using a Rabbit stream fan-out true in the configuration. So in configuration of agent and servers. So to migrate on that, it's not possible to do that directly with just restarting the services, but queue must have to be deleted, and it's the same for Quorum queue. We didn't say that, but yeah. And as I said, as long as producers are pushing message to this queue, it will grow and grow and grow, definitely. Unless you put some policy on it to define the max size, for example, of the queue. There is some other policy you can say. You can set a max age or. So in OpenStack, we don't need a really large history for message in fanout because it's mostly for streaming for broadcasting message to all consumers. So we don't need history. So here we have a max length of just 15 megabytes, and it's enough. So an example of one of our big region, graph 3. We were able to divide more than by 2 the number of queue on the broker. So now we are good. Almost, because we still did some other improvement. We just figured out that there was still some queue created, not used, mostly queue created by Neutron, because Neutron OVS agent is creating a lot of RPC servers. As I said, when you create a RPC servers, 3 queues are created. Now with stream queue, the fanout is shared between all consumers, but there is still 2 other queues. And sometimes those queues are not used at all because some RPC servers are just dedicated for fanout message. So for some of them, it's not needed to declare that. So we can still reduce the number of queue on the broker. About number of connection also, we can lower that with multiplexing some RPC servers in the same connection. So it's some improvement we did. We have to push that upstream, work with the community to do that.
So what we learned from this very long journey is that we increase the stability by staying up to date. So if you are not yet on the last RabbitMQ version, please upgrade. You will save some time. It will be better for you. If you, what we also learned from this is that we spend a long time tweaking RabbitMQ, but RabbitMQ is not a problem, actually. It's the way OpenStack consume RabbitMQ. It's not a queue broker, it's a message broker. So let's fix OpenStack, Oslo messaging, to create less queues, but more messages maybe. And we also learned that the community is very helpful, so as soon as you have an issue, feel free to send a message on an emailing list, and there is always someone which is very happy to say, hey, I have the same problem. But maybe they won't be able to help you anyway, but at least you are not alone. Do you have any question? We are maybe a little bit late, but we are the last from today's session, so we can maybe take a few more times for questions.
When you switch to the streams queues in the Rabbit, how do you solve acknowledging of messaging, ask? Because streams doesn't have echoing. Does they? Yeah? Because if you just put a message there, it is there, and you cannot just say, yeah, it is echo, because somebody else could read it if it just create an offset. Let's say offset -1 or something like that.
So yeah, there is still some hack of the message, but the consumer have to handle that. So the offset for one consumer is not tracked by the server, so it needs to be handled on the client side. So yeah, in Oslo messaging, for example, if there is some reconnection, for example, the offset is tracked, and at the reconnection, consumer is just reading from the same offset +1 to get the message at the point where the connection were broken. I don't know if it answers your question.
A short question about the RabbitMQ uses Nigia tables as their metadata backend store, and since 3.13, or mostly now in RabbitMQ 4, there's now the new Capri tables. Have you experienced it with them around, or is there performance gain for that?
So the community said, please do not test that yet. So we just waited, and yeah, we are still not on Capri. Yeah.
Hello. So we tried switching to stream queue for the fan-out queues, and we found that for Nova scheduler and Cinder scheduler, the messages the number of ready messages gets growing for HA clusters. So like having multiple controllers and multiple hypervisors. Did you encounter this?
So you have the message in the queue that are growing, right?
Yeah, it's normal. It's the way the stream queue are working. So that's why we have this policy at the end, because the number of messages in the stream will keep growing. But you can have a policy to make sure it will not consume your full disk, and it will get rid of the old messages after an amount of time. Yeah, so this is normal. And we were having this surprise as well, because we used to monitor the number of messages in queues, and a good OpenStack working is having 0 message in all of queues, but not when you switch to streams.
So can you share the whole command that was cut off on the presentation?
The command?
The command, the stream policy command was cut off, and I'd like to have it.
This one?
You may deny to. Oh.
Yeah, this one.
Okay.
It's cut off at the end.
It's cut off, yeah. Right. So, yeah. Yeah, better. So for this parameter, we just put a small size. I think we can do larger size. We didn't get any issue doing that. Just 15 megabytes. So
the screen is I think I think I proposed a patch on the large scale documentation to have this stream policy. So you can find this on the documentation on OpenStack side, I believe.
Here, stream max segment size byte is just 5 megabytes.
How much?
5 megabytes, yeah.
Hello. You may deny to answer because I think it's a tricky question, but we currently have most of our deployments, I believe it's on Antelope, which is before the change to the HAQs. Basically, our DevOps and our management team, I fried them to upgrade to Caracal because we understand that the upgrade recreates the whole queues, and that means that you have to restart basically every OpenStack service that is using RabbitMQ. So the question is, how was it for your end or for you? Or how did you manage with that?
So it's not free. Switching to Quorum is not free. First, you need to go to Caracal, yes, or to cherry pick back all the commits up to Antelope, right? Second, you need to set all of these parameters to true. And when you do that, you have to delete all the queues, stop every OpenStack service, and start over. Yeah. So you have to shut down your OpenStack completely. Yeah. So it's not free. Yeah.
So there's no way around.
We did that. So we ask our customer, we will shut down the API for like 1 hour, and we will upgrade the RabbitMQ cluster, switch to Quorum, switch to Stream, and turn it back on. This is what we did.
So half a downtime.
1 hour.
1 hour?
Yeah. You can do that quicker if your region is small. It depends on the scale.
Sorry for another question. What we were also using stream queues and the Quorum queues already. But what we saw in the last 2 years that Rabbit consumes a lot of wear out on our SSDs. Is that something you also saw? Because it's now, I think